Welcome to this lesson on functions and equations. Please make sure you have these notes in front of you so we can begin our lesson. The first learning objective for this lesson says I can write an equation for a function table, and the second one says I can graph an equation for a function table. Our first vocabulary word is called linear function, and a linear function is a function whose graph is a straight line. The word linear means forming a line, because I can see the word line in linear. The everyday definition of a function is the purpose something is designed or exists. So think of a set of stairs. A set of stairs, the function of that set of stairs is to get from the bottom floor to the top floor, or to get from the top floor to the bottom floor. The function of a cup is to hold some type of liquid or water so that you can drink it. Everything usually has a function. The next one says, what do you notice about the graph? So if you look at the graph right here, I notice it forms a line. And that blue line is a nice straight line that is constant. It continues to go up and up and up. And the math definition of a function is a relationship that assigns one output value to one input value. So in previous lessons, we've already talked about what our input or our independent variable is, and our output or our dependent variable is. Please know that the input or the independent variable is the x value, and the dependent variable or the output is the y value. So if I had the following ordered pairs, I can graph 1, 2 here, I can graph 2, 4 here, and I can graph 3, 6 here, and notice when I connect them they form a nice straight line. So let's use these key concepts to discuss the following examples. So example 1 says write an equation to represent the function shown in the table. So all they're asking us to do is let's go ahead and figure out what the rule is by putting the input value into a function machine to get the output value. So if I look at this first one, position 1, or day 1, I have $9. Position 2, or day 2, I have $18. Position 3, or day 3, I have $27. Position 4, or day 4, I have $36. And day 5, I have $45. So to get from 9 to 18, I can add 9. To get from 18 to 27, let's add another 9. To get from 27 to 36, we can add 9. And to get from 36 to 45, I can add 9. So notice I'm adding 9 every time I move to a different position. So if I look at this as repeated addition, a shortcut to repeated addition is to just multiply by 9. So I'm going to multiply all of my input value by 9. So the first thing I would do is I would take 1, which is my input value, put it into the function machine, times it by 9, and when it's out of the function machine, it's going to become 9. Notice that's my output value. So I'm going to take 2, which is the input value, plug it into the function machine by multiplying it by 9, so 2 times 9 gets me 18, which is for the second position. Let's go ahead and take 3, our input, and plug it into the machine by multiplying it by 9. 3 times 9 gets me 27, which is the third position for my output value. Take 4, which is the input it into the machine and multiply it by 9. 4 times 9 gets me 36. And then let's take 5, plug it into the machine, times it by 9, and my output value becomes 45. So all of the output values are the dependent variables because they depended on the input values, which is my independent variables. So now they're asking us to write an equation. How do we get our output value? By using the rule and our input values. So I can write my rule like this. My output value, or my y, has to equal 9 times the input, which is x. The input could be any single number. So this is the rule, or my function equation, for this table. So pause the video and complete this guided problem, and we'll discuss this answer in class tomorrow. Example 2 says graph y equals 2x. So in this case, they're giving us the equation. So for step 1, they want us to make a table of ordered pairs. Select any 3 values for x. So I'm going to start by saying 0, 1, and 2. Those values I'm going to pick as my input value. So I'm going to go ahead and place 0 inside of the function machine. So I'm going to take the rule of 2 times 0, which is the input, and when I multiply that out, the output number should be 0. So the ordered pairs for this problem would be 0, 0. Let's go ahead and take the second input value, which is 1. So I'm going to plug it into the machine, 2 times 1, and my output value becomes 2. But my ordered pairs now becomes 1, 2. And let's take the last one, which is 2. Let's plug it into the function machine. So 2 times 2, my output value becomes 4. So my ordered pairs become 2, 4. So now that we've created our ordered pairs, step 2 says to graph each ordered pairs and then draw a line through each point. So my first ordered pair is 0, 0. So I'm going to start at the origin and place a dot right here at 0, 0. My second ordered pair says 1, 2. So on my x-axis, I'm going to move over 1, and I'm going to go up 2 spots. So there's the second ordered pair. And the third ordered pair would be 2, 4. So I'm going to go over 2 on my x and up 4 on my y. And then I'm going to connect my dots using a nice straight line. Notice I have a linear function here because the graph forms a nice straight line. So pause the video and complete this guided problem, and we'll discuss this answer in class tomorrow. Example 3 says Mario constructed the graph shown, which shows the height of his cactus after several years of growth. So according to this graph, after 1 year of growth, the cactus was 42 inches tall. After 2 years, the cactus was 44 inches tall. And after 3 years, the cactus was 46 inches tall. So let's make a function table for the input and output values. Our input would be everything on the x-axis, and the output would be everything on the y-axis. So if I'm looking at my graph, years of growth, after the first year of growth, that's the input, the cactus was 42 inches tall. After 2 years of growth, that's the input, the output was 44 inches tall. And after 3 years of growth, that's the input, the output was 46 inches tall. So we've just completed the table. Now let's go ahead and write an equation from the graph that could be used to find the height y of the cactus after x years. So let's take a look at the patterns from our outputs. If I add 2 to 42, I get 44. If I add another 2 to 44, I get 46. So if I keep adding 2, that's repeated addition, or the shortcut to repeated addition is to multiply by 2. So I can start the rule by saying if I take the input number and I multiply it by 2, I should get my output number. So I'm going to place times 2 in the first part of the machine, because any type of input that I place into it, I want to multiply it by 2. So let's look at our first input. If I take 1 and I place 1 into the machine, I have 1 times 2, which gets me 2. But that does not get me 42, which means it has to continue on in the function machine. And in order to do that, I need to add 40 to it. So if I add 40 to it, the output becomes 42. Let's try another one. Let's take 2 and plug it into the machine. So 2 times 2 gets me 4. But it has to continue on in the machine, so let's add 40 to that, and that becomes 44. Let's go ahead and place 3 into the machine. So 3 times 2 gets me 6. 6 plus 40, it's continuing on into the machine, gets me 46. So what happens if I have like an unknown number for my input? If I take that unknown number and say x times 2, I get 2x. Then we need to add 40 to that, and that will get me my next y value. So my equation for this would be y is equal to 2x plus 40. So pause the video and complete this guided problem, and we'll discuss this answer in class tomorrow. So now that we've finished this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss this in further detail.